Hello, everyone, and welcome to today's Masterclass session, Benchmarking VDI Performance and Digital Employee Experience, and I'm really thrilled that you've joined us today. Before we dive in, let me ask you something. Have you ever tried to describe a powerful experience like being at a live concert or hiking up a mountain to see the view from the top? You might mention the 100 decibels of music or the 3,000 feet of elevation gain that you experienced. But numbers alone can't capture the feeling, the goosebumps during the encore, or the awe of looking out over the valley below. Digital employee experience works the same way. You can measure CPU, memory, and latency, but that doesn't always explain what users are actually experiencing. And that's the gap we're here to talk about today. This session is all about learning how to benchmark VDI the right way, not just by measuring system load, but by capturing what users are truly feeling. Joining us are two of the most respected minds in end-user computing, Dr. Benny Tritsch, performance scientist and creator of the EUC score tool set, and Michael Schuster, CEO of Frustrate Systems. Together, they'll discuss how to scientifically assess digital employee experience using telemetry, real and synthetic workloads, and even screen recordings to expose the true performance of your VDI environments. So whether you're an architect or an IT leader or just somebody who's tired of flying blind when it comes to VDI, you're in the right place. So let's get started. I'm going to pass to Michael.
All right, thanks very much, Erin. And Benny, I just want to thank you once again for joining us. I've been a fan of your work for quite a while, and I think it addresses a interesting gap in the market. And you've always bring a lot of interesting dialogue and thoughts on this element of DEX within the ecosystem here. So I'm excited to have you join us and be sharing this information with our viewers, both current and future. And a little bit of Frustrate Systems. We're one of the we're an end user infrastructure company out of Toronto, Canada, and we also service the US and have presence in the US as well. And we focus on digital workspaces and having been involved in some of the largest digital workspace employments in the Americas, as well as our specialization in a number of key practice areas across endpoint management and infrastructure, network and security, and so on and so forth. So without further ado, let's take a look at the agenda here.
All righty. Can you see my screen?
Yes, we can.
Good. So, Michael, you want to walk us through the agenda, or you want me to do that?
Sure. Actually, Benny, why don't you give this a go? I think you're probably going to build that a bit more than I will.
Okay, the agenda is going to be very simple. But before we get started, thank you so much for inviting me to join you for this masterclass. I really appreciate it. And I mean, I'm an independent expert. That means I can look into all these technologies without any bias, and that is an advantage. Because even the vendors come to me every once in a while and they want me to test their VDI solutions because they know that I'm independent, that I don't lie. It took me more than 10 years to build this reputation that even though things may not work as expected, I'm going to tell the truth. Sometimes marketing doesn't like that. But we're going to talk about the spectrum of Windows desktops, what today's situation is, and hosting Windows in the cloud. What is the difference between end-user computing and DEX from my perspective? And then we're going to look at some screen artifacts and anomalies, just to make clear what this all means. And this brings us to the end-user computing quality criteria, how end users see them. And now, if we want to measure all that, we need to simulate workloads that represent stuff that users do, but break it down to the individual application types so that we know what works and what doesn't. And in the end, we're going to talk about personas and requirements and VM types as a summary. So without further ado, let's go into it. So it all started with on-prem Windows, as we all used to use it in the past. Today, more and more people are using VDI or remote desktop services. Many of our customers in the end user computing market, they did that in LAN environments, or they well, gave their branch offices access to the resources that they hosted in their headquarters using their own networks. But now we're talking about the cloud, Azure Virtual Desktop, Windows 365, and all the other variations that build on top of that.
Yeah. So the goalpost is really moving with as far as where the last mile is, suffice to say, over time.
Absolutely, absolutely. Well, it's like a service. Everything is a service, and this is where everything goes now. Now, what is the challenge when you host Windows in the cloud? I mean, you have a remoting client and you connect to the remoting host. That is the first step. But then you interact with the remoting host over the VMs that are hosted on the remoting host. And that goes through the cloud connection. And this comes with latency. Now, we process all the interaction on the remoting host side, and there the rendering happens in the frame buffer. So the frame buffer on the host side is being captured and encoded, and then we transmit the data, the screen data, over to the client, again through the cloud connection. And there everything is decoded and displayed. And all these individual steps come with a certain latency. And that is nothing we can fix. It's physics. It's Mr. Einstein's fault, because he said that there is the speed of light, and that it's not possible to transmit information faster than that. Yeah. So basically, we're limited by that kind of latency.
I mean, there is services that are available to sort of shorten that path, especially in the internet. Especially there's just various vendors or SASE providers have got ways to sort of shorten that path, so you're not sort of taking back roads to get from A to B. You're taking highways, if you will, through better routing paths. But at the end of the day, you're absolutely right, especially when you got users connecting over the internet to your because frankly at this point the internet is the new LAN essentially at this point for most businesses. So yeah, you can speed it up and reduce latency as much as you possibly can through optimal routing and whatnot. But at the end of the day, you cannot solve for latency, period. There's only so much. You're absolutely right.
I agree 100%. And this is why all the VDI vendors are very actively working on new versions of their remoting protocols, because they want to create those short paths. Mm-hmm. They want to introduce predictive technologies. They want to introduce technologies that help to remove artifacts or anomalies, which we will be covering later. And if you look at cloud Windows, what are the influences of the user experience? And it's clearly the VM type. Well, we're going to talk about that at the end of this session. The client device, the endpoint, if there's a GPU or not, both on the endpoint device or on the host system, and the network, as we already mentioned, and the remoting protocol. These are the critical factors. And if one of them fails, the entire user experience is not good anymore. Simple as that. And now the question is, how can you score that? How can you measure that? Because you can only optimize what you can measure. I call that DEX for DaaS, like the digital employee experience for the desktop as a service experience. So that was the sort of an acronym that I started using for that. But there's another way of looking at it. You saw in the agenda that there is this differentiation between end user computing and DEX, digital employee experience. So I personally see the end user experience, the admin experience is more the classic EUC market, because all the vendors did it for the admins. They were their target audience. And this is why all these management consoles were built and everything to please the admin, which is also very important, specifically now that we have more and more unexperienced administrators, not because they don't want to know about this technology, but it's a bigger group of people managing EUC environments. And very often in customers, it's the generalist rather than the EUC expert. So it's our job to simplify everything on the EUC side, on the admin side. At the same time, we need to make sure that the end user experience, which is more soft metrics, like what does the user really see, which is really hard to experience from the admin side. Michael, you had something?
Yeah, yeah, just a couple things of that. I mean, the metrics that we usually see, the hard metrics we're talking about, CPU, RAM utilization, and pressure and whatnot, and disk queue length, disk queue depth, and all those good things. Like from an administrator's perspective, that can be very useful for giving an indication of how things might be performing and might indicate what the user might be perceiving performance-wise. But we all know, having been in this field long enough, that's not always the end all. We've certainly seen cases where certain metrics look good, but the actual user experience when they're actually in their session clicking stuff and interacting with their application is hot garbage. Or sometimes even it's the reverse. Some of the metrics like crap, and latency's through the roof, but because of how well the protocol's doing, the user, it's not as obvious to the end user. And we've been seeing the shift in the last few years towards this whole concept of DEX, digital employee experience, where and we're seeing this not just in the end user computing space, but in a number of different areas of technology, where we're really putting more an emphasis and a focus on, well, just as it says, what is the perception of the consumer of that service, that technology, that application, whatever it is, what is their perception, and how do we actually understand that better and score it and track it in some way so we get a better understanding of what's actually being experienced here. And it's something that, once again, a lot of vendors and technologies are getting on board with this. You're seeing a lot more tools that are throwing decks everywhere, and it's a good move forward, and we're excited to see what's going to be happening on this. Some are a little bit better than others in that space, but at the end of the day, just as you said there, like this whole field and technology in general, especially for business, is evolving so fast that no one wants to become an expert in understanding the dark art of tuning 50 different policies to squeeze as much performance and user experience and frame rates or whatnot out of a given product, where they really just want things to be almost set it and forget it. There's a few there. IT admins and users are expecting that the vendors are rarely just creating adaptive technologies that can take a bunch of signals, auto detect what's going on, and optimize the user experience and the remoting protocol in this case without having too much involvement. Everyone's in our field now has got so much to worry about. Now it's AI, it's also security, it's this and that, where they don't want to be experts going 1,000 feet deep in little niche areas. They just want things to work because they've got so many other things to be working on, right? So I'll get off my soapbox on that point.
Absolutely. And it doesn't mean that monitoring tools are not needed anymore. Absolutely not. There are great monitoring products out there. You need to add a little bit more of the information from the other side, from the soft metrics. And I'm going to show you some examples in a minute, because when I'm talking about screen artifacts and anomalies, here's a terminology that I'm using. And I mean, I will not go through the individual words. You can find them on my website, or if you're able to download the slide deck, you can just look at the slide deck on this slide. I didn't come up with these terms. It's something that is used since, well, many years in the film industry. So because they are the ones who were dealing with all these effects, with all these anomalies in the past and also today. And this is why they have words for all these different things that can go wrong on the screen. And to give you more perspective on that, this is a typical example of like those block elements that you can see if there is not enough bandwidth available. So these are block artifacts, and you can see them if you see, conference calls every once in a while. You see these effects as well.
But a VDI monitoring tool is not going to pick this up.
No,
there's no VDI monitoring tool that's able to detect. Here's different pixel issues or whatnot we got going on the screen or artifacts, right?
Same here. It's a smearing effect that happens because there are some frames that were not delivered properly in a video. So there are keyframes and there are delta frames, and there was a missing keyframe. And so the delta frames that only include the delta between the previous image And the current image, well, they apply this to the wrong image, and so it smears across the screen pretty much like you smear color painting on a canvas.
Now, granted, this could differ based on the different protocols, right? Because what you do is essentially as I think you mentioned earlier, it's protocol agnostic. So whether it's RDP or NICE or HDX,
I will not tell you what
have
protocol that was.
But the point is, they can optimize however they want to sort of improve this. But at the end of the day, these are challenges that pretty much all the current protocols have in some way. They just try and compensate and deal with it in different ways.
Well, I try to reproduce things that users describe, and sometimes it's hard to understand. Can you imagine how an end user wants to describe that during a support call? It's almost impossible, because this looks
they're
like
really good at the
drugs.
snipping tool really quick. They may
be able to, or using your phone, and take a picture and send it over. That's the only way. And sometimes I feel like a wildlife cameraman, being out there in the wilderness and taking that kind of pictures and being able to show them to you. That's another one. A color artifact when you were scrolling in a standard text. A very, very frustrating thing for an end user if they encounter that, and really hard to reproduce. I got to tell you, that's the kind of tests that I run for the vendors. I try to reproduce these things that they describe are happening at their users, and then as soon as we can reproduce it in a lab, then they can fix it. It's much harder if you are hunting such a bug without knowing how to produce it. So that is my job very often.
I got to ask one thing, Benny, because I am curious. What vendors are usually engaging you for this type of work, and why? Just real quick. I don't want to derail too much.
It's vendors like Microsoft and Citrix and AWS.
Hardware vendors too, I think.
Huh?
Hardware vendors too, of some like as well.
Yeah, I did testing for Igel actually when they still had their own devices, client devices, and then when they switched to the third-party client devices, they wanted me to compare the performance and the end user experience, and trying to improve the quality of their client software that they implemented on their Linux devices. Which was also fascinating for me to do. This is a stripe artifact, which happens when you have packet loss. So some of the protocols respond that they produce these stripes because they don't have the data. And this was a fascinating thing, but that's years and years ago when, the color lookup table was wrong. It was supposed to be blue water. But the color lookup table was not correct. So for like 5 seconds at the beginning of the test sequence, the water was red while it was being rendered. And I always said, oh, there must have been a shark in the water. So this is why the water is red. After 5 or 6 or 7 seconds, then suddenly it updated the color lookup table and the colors were correct. But at the beginning, it was false colors. And that brings us to the point where, so what, from a user perspective, are the EUC quality criteria? And some of them may look very familiar, like the boot and the logon duration, the application and content load time. This is something that the monitoring vendors, most of them can measure in a very, very good way. So this is part of DEX. But the question is, and Michael, I know that we had this conversation before, how important is the logon duration if you work the entire day in a
exactly. I mean,
desktop?
logon duration for certain use cases is hypercritical. I mean, if you're in healthcare, or there's been a grocery store chain I've worked with where they process 12,000 logons every hour, right? You cannot wait 2 minutes for that session to come up.
Absolutely.
That's just can't happen, right? So but if you're logging in once during the day in the morning and it's 2 minutes, sure, that's a poor experience. You really want to be about 40 to 60 for launching a full VDI session, ideally, if not better, which it can do in certain circumstances. But the point is, if you're running for a whole day and it was a 2 minute, 3 minute log on, that sucks. But in the grand scheme of things, that really should get weighted far lower, right? So depending on the use case or whatnot, some of these metrics might need to be weighted in a certain way to not be as relevant. So for each
Yes.
use case, it tends to be a bit unique, right?
Use case and, well, the user persona. Some users are more sensitive to that kind of well, quality criteria than other. The ones that I specifically focus on are user input delay. Is the graphics API supported? That's something that most monitoring system cannot see. For them, everything looks green because if the user clicks an application that is not supported, the application will not open. It may crash. So you may see it that the application crash dump or the crash metrics will go into a monitoring system. But all the other metrics like CPU, like GPU, like memory, they stay on green because the application crashed. I want to see those crashes. I want to see if the media formats, the videos are supported, or if effects like we saw earlier with the smearing of the video, if that happens under certain network condition, and the distortion of media, the screen refresh rates. These are the important things.
Tell me about
Endpoints.
screen refresh rates real quick, like frames per second. I think how relevant is that?
It depends on the persona, to be honest with you. If you are a media designer, if you create videos, then the screen refresh rate is very, very important. You want to have 60 frames per second, 60 hertz. If you're a CAD/CAM designer, it doesn't really matter so much. Even if you only have 30 or 20 frames per second, everything is acceptable as long as the user input delay, like from clicking on an object and moving or rotating the object, that is a lot more relevant if it is immediate, like snappy. It doesn't matter if it's only 20 or 30 frames per second. I had customers where these users would not be able to differentiate between the 60 frames per second and the 30 frames per second. It's irrelevant to them, but not for the media designers.
So in essence, just like you said, getting into this, we really got to understand our end user requirements and their personas and use cases to understand what's hypercritical. If FPS doesn't matter tremendously, as long as it's not like 5, then why try and spend a lot of time and effort trying to optimize and get 60 when it's just not relevant to the actual.
That's totally true. And the last 3 endpoint specs, application reliability, session consistency, resilience, that's again something that many of the monitoring vendors can do really, really well. So I try to focus specifically on those aspects where, well, the end user sees the results on the screen and may not like what he or she is seeing.
Endpoint specs, I think, is particularly interesting just from my perspective, because especially found this during COVID. We had customers that in some cases that would run out and said, oh, we got to move everyone out of the office remotely, and we're going to ship them all a bunch of thin clients. And because this was something they didn't budget for, they got bottom of the barrel thin clients. And suffice to say, for their given use cases, whether it was audio offloading or it was graphics intensive or whatnot, there was no GPU in the endpoint that the given codec that the VDI platform could take advantage of. They were having, suffice to say, not a great time. It's important. Do not underestimate, especially when you've got demanding use cases, the hardware requirement recommendations for your endpoints to provide a good user experience.
And this is exactly why sometimes the, like the thin client vendors ask me to do some testing, because customers always blame the thin client, but thin clients come with a GPU. So they are very powerful.
Well, some do, but some do. But it just moves the point home as why there's a couple of tiers of thin clients, right? You've got entry level, mid level, and higher end ones for this very reason that we're talking about.
Absolutely. And now here is the way that I'm testing all that. A very simple test lab is I connect from what I call the primary device. There may be secondary device if I have multi-user environments, the noisy neighbors. But I want to always look at it from my primary user, from the primary device. This primary user may just, you say, in North America, you say mouse around. So click somewhere and, well, interact with applications. That's something that you can do on a system under test, like a host system and a VM, and you're connected to it through a remoting protocol, and you start interacting with the system. But then if you really want to make that reproducible, and that's a scientific approach, make it reproducible, we need simulated workloads. And run these simulated workloads and collect telemetry data, the standard performance counter data, and collect activity log data, like the simulated user clicked here, and then the simulated user clicked there. And it always happens in the same way, so that if you do it on multiple systems, you can compare it. So that is a simple test lab. And you can download the free version of my tool set and can just run these like 20 or so of these simulated workloads. I'm going to give you the links to this download later. But what kind of simulated workloads do I have? The type 1s are the ones for the primary user, representing different application types like GDI application, DirectX, OpenGL, video, all these different types of applications separately, because I want to find out if the system performs well with standard GDI or DirectX applications, or if it's specifically well designed for videos and OpenGL, which requires a GPU. A GPU is mandatory for most OpenGL applications. So this may require pre-installed applications. So I'm using some standard applications. Sometimes I even go so far and use the standard benchmarks like SpecViewPerf and run them on a system under test as a primary user and record all the interaction and all the telemetry data. And I have personas. These are for the noisy neighbors to run, well, these kind of workloads in sessions that I do not have in focus, just to create that noise, the background chatter, basically. And I can find out, oh, how does it impact the primary user if I have 5 noisy neighbors, 10 noisy neighbors, 50 noisy neighbors. In VDI environments like Windows 365, doesn't matter. In multi-user Windows 11 in Azure Virtual Desktop, absolutely does matter. So this is why I have these type 2 workloads. And then a type 3 that creates a score, but only for that kind of workloads where, well, things that are happening on the screen, the endpoint matters here. So like, how long does it take to open a dialog box? And some of the remoting protocols cannot open the next dialog box before the first dialog box was opened on the client device. So it's a handshake mechanism. So I can try to open as many dialog boxes as I can and measure how many I can open. And sometimes this gives me a very good indication how good the communication of the remoting protocol is. So that's why I have 3 different types of workloads. And then I use the simulated workloads, the telemetry data, the user activities, plus, you mentioned it earlier, screen recording. And this is used for scientific data analysis and the visualization. So the lab is a little bit more complicated then. We still need the primary device. We still connect to a system under test. We still have simulated workloads, but then we have a very sophisticated mechanism to collect telemetry data. I call it the avatar. So that is producing a better telemetry data set. It's still the activity log. Now we add a WAN emulator because we want to simulate crappy network conditions and see how...
Or a user that's like on the other side of the continent or on another continent entirely.
And have a conversation with the network team and ask them, hey, are you able to give me the data of what the connection quality and what the specs are of the connection from users that log in from a remote office, from a branch office. And most of the networking teams, they have this log data and they're happy to share that. And then I can feed that into my WAN emulator and reproduce the setup as if somebody logged in from a remote place. And the other thing is I use screen capture devices and a video recorder PC that records the screen videos. And as soon as I have that, I can still do the playbook thing, because sometimes my synthetic workloads are not good enough. So we need to create playbooks like, hey, I want to open this application that only runs in a end customer's environment. I do not have access to neither the application nor the data behind it. So I do that on site when I go to end customers. And so the users there, they click through the interaction with one application. I try to limit it to 90 seconds, like 90-second playbooks. And so that is also reproducible. So that's the idea of these playbooks if you have this advanced test lab. And then I'm going to feed all the results into, well, a video player on steroids. Because I not only have the videos, the screen videos that come from the endpoint device, I also have the activity information, and I have the telemetry data. So you see screen video, activities, telemetry charts, and then I put that into a video player that plays these things in a timely synchronized way. I never wanted to build that myself. Unfortunately, nothing like that was available in the market. So I went through several iterations of building something like that. Today, it's an HTML5 application, and which makes it run in every browser, which is a big advantage. So everybody with a HTML5 capable browser can see all these results. These are screenshots of what it looks like. I'm going to go and show you some real examples in a moment. But just to give you an idea, this was something that was created by a partner. They wanted to test by Auxilium IT in Scotland, and they wanted to find out what the storage performance is in Azure Local. So they have their reference lab, Azure Local, and they did a lot of testing. So this is the link. They were using the EUC score toolset and the methodology that's behind it. That was a fascinating project. It's not the end user experience, it's the admin experience. Nvidia wanted me to compare what it's like for the admin when using the native AVD console and when using the Nerdio console. What kind of benefits does it bring to the admin looking at the EUC market, as we discussed earlier, where the admin is the relevant person. While these tests, CPU only VM types, people wanted to know how good does an standard AVD VM perform when compared to Windows 365 standard. And you see, when I do that side by side, it's color coded. Like the yellow color on the left side, the red color on the right side, and playing these videos at the same time and seeing the telemetry data with the same color coding. There's a report button. If you look at the right bottom, I call it the boss button because it shows the results of the observations and it hides all the telemetry data. Because decision makers, they don't know what to think about the telemetry, but they know how to compare videos. So what the performance is on either side. And this is the same GPU-enabled VM types that you find in Azure. And here, before looking at the different personas and the VM types, let me just show you an example of, well, an example of a comparison. Like here, I had Windows 365 with GPUs, with a GPU under network constraints. Microsoft was friendly enough to give me access to these VMs and allowed me to share the results because they want people to learn what it means. And so, like I said, what I did, I ran some of the simulated workloads, the sim loads, and here you see the network comparison, like 100 megabit versus 8 megabit, 10 millisecond latency versus 110 milliseconds, 0% packet loss versus 2%. I have it here on my local system just to show you like the 2% packet loss compared to no packet loss. And even over Zoom, you should be able to see all that.
Yeah, to get some
And
indication of,
and you
of how
see
that's working.
it stops on the right side, on the red side.
Yeah.
So, and this is created by the packet loss. This is the user experience. Everything is smooth on the left side. On the right side, it is not. Even though it uses exactly the same CPU performance, CPU,
That's a good point. Yep.
everything is almost identical, except for some of the network. You can see the hiccups in the network. All right. This is what the effect is. If you are a very experienced IT admin, you'd be able to see this, but you would never be able to see the result, the user experience. If you wanna see that kind of results yourself, just go to my drtritsch.com website, because I have those articles where I publish that kind of results, and you can run these side-by-side video comparisons in your own browser. And so you will be able to see it much better than we see it here over Zoom. This is what I want to recommend. In the end, you get all the links to go to this website. So coming back to this slide here, I mean, as we discussed before, we have these different personas. You see the VM specs. These are the recommendations. What kind of VMs should you use for that kind of personas? What kind of network conditions are required? And you see, for a task worker or information worker, you neither need a GPU nor a very good network connection. But if we go down here and we have a media designer, CAD/CAM designer, power user, things look differently. You may need a GPU. Down here with the CAD/CAM designer, you clearly need a GPU because most of the CAD/CAM applications are OpenGL applications. So low latency, almost no packet loss, high bandwidth, and then we're talking about the expensive VM types. Is that something
and across
that
a number
reflects?
of, So go ahead.
Is that something, Michael, that reflects what you see in your customers?
Yeah, but at the end of the day, I mean, especially when we're going through sizing exercises, we have to use data, the best data that we have available from the customer's current environments and what's our own field experience and what we know of and what's made available from the actual platform vendors, whether that's purely Microsoft or Microsoft plus the overlay from an Omnisa or a Citrix or what have you, right? Based on what their protocols are using and whatnot as well. But at the end of the day, this just reinforces the fact that there's a number of different factors that influence the what the end result of an end user experience is going to be when they're consuming a given workload, right? I mean, CAD/CAM designers and media designers have clearly got higher to run those use cases well and with good experience. In this case, with Win365, it's evident that they do need a sizable VM instance with a good GPU, and there really isn't much tolerance from a latency and network quality perspective as far, or you can't get away with having too much of a shitty network, and that really informs being able to have those conversations with the business to say, great, if you are this type of use case, we got to be realistic about how well this user is going to perform, because we can make sure that we're sizing and using and architecting the solution to use certain types of VMs and GPUs or whatnot. But that also, it even making sure that we're giving our users the right endpoints, but it doesn't negate in any way the fact that we don't control the last mile that users are using, and that does play a role for these other use cases here. So we need to have that. This is helpful in order for us to have better conversations with the business, but not to say, great, we can provide you this, but if you're looking for this level of quality and capability to do your work effectively, you can't expect that you're going to be off in a cafe in France connecting to a workload over in geez, I don't know, Montana or something.
Yeah.
Just and expect that you're going to be having a rock solid experience, because there's just too much demands that your workload is placing, and too little tolerance in these areas to be effective right that right. So it allows for expectation setting and requirement setting, because there's only so much that IT can be responsible for, right? And expectation setting, it goes a long way in terms of
And this is
communicating expected outcomes.
this is exactly why I'm using those videos for the decision makers and the budget owners.
Yeah, picture's
Because
worth
for them,
1,000 words.
the telemetry data doesn't really matter. But if you show them, look,
Yeah.
if we have this protocol, if we have it in this data center, this is the user experience. In the end, they make the decision. I can only create those reference videos and can show them, look, this is what it looks like. Here's the price tag on the red side. Here's the price tag on the yellow side. You are the decision maker. You decide what's good enough for your users. But do not complain when you buy the wrong solution and your users are not happy, because we showed you what it's going to feel like for the users. That's
at the end of the day, we're so used to load testing and doing and just using data from real world users or whatnot. That's all well and good if we're using conventional monitoring tools for collecting metrics, but getting metrics from conventional tools really give us an assumption on user experience. It doesn't always indicate
that's
this
the
is
same
what
here.
the user is actually experiencing, right?
Yeah.
The EUC score system that you've got running, it gives more definitives, or as close as we can get to seeing what users are going to experience as under different network conditions and configurations within the remoting platform, right? It's performance monitoring from the end user's perspective.
Exactly. So benchmarking is never, the real world. It's always a synthetic world, but it gives us a good idea of what the performance differences are between what you said, different network conditions and all of that. And so we can make educated decisions during our design of a VDI infrastructure. Right. So with that.
Wonderful. I'm just going to remind everybody, we're going to invite you, if you have questions, to please go ahead and ask your questions in the Q&A chat. We invite you to have those now. And yes, I'll pass back over to you.
All righty. I mean, here, the call to action is, if you want to learn more about EUC score or the results collected, and as I promised, here is the page with all the links, like also the freeware download. If you go to eucscore.com, there's a freeware you can just download without registration. It's going to be a handful of no, more than a handful, almost 20 workloads, and I can show you what it looks like when you run this, because here on this machine, now let's see, here I have my video recorder and this screen capture card that is connected to this machine here, gets the signal from my test client. And if I run one of these tests, I can just click here. No, it's not showing. Why is it not showing? That's funny. I'm obviously on the wrong machine. Frame grabber.
Happens to the best of us.
The demo gods were not with me. Okay, let's close that and open it again and see if it works. I only give it one try. Look at that. Now it works. Okay, let's stop that so that you can see it again. So I'm moving the mouse on my reference client connected to my Windows 365 instance, and I run a workload that includes 6 simultaneous videos. And as you can imagine, that's the kind of workloads that may have the potential under not so good network conditions to break it, like some of the stuff that you have seen before. But this is what it looks like when I run those tests. I start recording, and I have everything that's on the screen of my test device here. And
So do you have an
WAN
emulator running right now, or on that? Do you have a WAN emulator running on that example, or is that just straight through?
This is straight through. Okay. I can open the WAN emulator, and but this is without any constraints.
Gotcha. Okay.
The full bandwidth that's available, but that's what it is. Are there any questions?
Again, we invite you to go ahead and ask your questions in the Q&A chat. And I do have a quick question here. Did the benchmarking test show what remoting protocol is best?
That is a very common question. What remoting protocol is best? And I have the typical consulting answer for you. It depends. And it always depends on the use case. And I found some of the synthetic workloads work well with one protocol and not so well with another. And with another workloads, it's exactly the opposite. And some of the remoting protocols are specifically well designed for like media and CAD/CAM use cases, but not tolerate high latency and packet loss. For example, Teradici PC over IP that was acquired by HP was specifically designed for media designers. So like Hollywood studios would be using the PC over IP protocol when they connect to rendering farms to render their movies or scenes in their movies. And this is their sweet spot. So they will lose when you compare other setups. But when it comes to color accuracy, this is where all the investment went into when you look at PC over IP. Now they're working on also catching up with the other aspects, but this from the get-go was their sweet spot. This is a simple example that you cannot generally answer that question. For some of the use cases, you can answer those questions, and for bad network conditions, historically, Citrix has always been very good dealing with high latency and high packet loss rates, for example.
That's great.
So I got one question here I got to ask for myself here. So this has been a lot of good information. How do IT admins that are in any way responsible for end user experience and VDI and remoting applications and desktops within their organization, how do they operationalize this stuff practically to make use of it?
I have a couple of customers and in particular partners like Auxilium IT that I mentioned earlier, who tested their Azure local environment. And let me show you what kind of information I gave them. So here is my lab setup, and I gave them sort of a 2-day training class where I walked them through how to set up everything in a way that I have it in my lab. So here on the left side, you see the screen of the reference clients. That is the real screen that you were seeing when I was running those tests earlier. And the recorder was here on that screen in the middle. This is the screen that I share. So these colorful screens, they are connected to my video recorder PC. And here in the middle, you see these, these are my standard reference endpoint devices. And the Auxilium IT folks, they build exactly such a lab following this example. It's not extremely expensive stuff, except for the WAN emulators. The WAN emulators here, you see the most expensive one, the blue one here. that has a list price of $20,000. So this is by far the most expensive device that I have here. This one here on the right side, that's also a WAN emulator. I have 3 of them. 2 of them are these smaller ones, and I bought it on eBay. So sometimes people sell it on eBay. Check it out. So I bought it for 600 euros in the UK. It was fascinating sending things from the UK to mainland Europe these days. It's a lot more complicated than you would think after Brexit. But this is what I did only recently to see how that goes. And 600 dollars or euros. This is sort of the most expensive device, and you have the reference client devices, plus you have a recorder PC, which is a standard PC. And when you build like one of those, well, test setups, this is what the Auxilium IT folks and also Ruben Sprout, I'm working a lot with Ruben Sprout from Dijon, he does a lot of testing. And what they said is, as soon as they have this lab with all the screen recorder and everything connected, they just connect to some new thing that they find in the internet, and they record it, they collect the telemetry data, and it becomes like a daily routine, or at least a weekly routine, using this technology. And as soon as you get familiar with it, then it is part of your QA routine. And I got to tell you, some of the biggest vendors on this planet, they do exactly that. They bought a license of the EOC Score toolset, an enterprise license, and they use it for their QA. Some of these, vendors do not even tell me what exactly they are doing, because I give them, as part of the enterprise license, access to the source code of sample workloads. They built their own simulated workloads and run those as part of their QA process. And they use it daily. Everything can be built completely automated, and then they run these tests, they record it, they compare before and after. Like, hey, the product managers, they love it. They ask the developers to implement something new, and then they want to see if it improved the end user experience or not.
I still can't get over the $20,000 WAN emulator. Like,
WAN
that's a lot of money
emulators
to
are really
spend
expensive.
to get. That's a lot of money to spend to
Yes.
force a shitty experience. It's like up there with going to a French fashion house to get ripped jeans.
There are software WAN emulators, but as soon as you work for the large vendors, they demand that you use hardware WAN emulators, because software WAN emulators are not as accurate. If you tell them, oh,
Fair.
I want to limit the bandwidth to, I don't know, 10 megabit. So sometimes it goes over, it goes through this threshold for like a second or so until the limiter kicks in and then reduces the bandwidth. While these hardware WAN emulators, no matter what, you're gonna hit that limit, and it's gonna be maximum 10 megabit, nothing more. So this is the big difference between software and hardware WAN emulators. Yes, and they're expensive. They are the most expensive components in my lab, I gotta admit. So if we scroll up here, not even my recorder PC with like a beefy CPU and the Nvidia graphics card, no. Compared to the WAN emulator, to the best one, it's cheap. More questions.
This stuff is fascinating. I do have time, I think, for one more question. And we talked a lot about matching devices to use cases and personas, but I'm curious, is a GPU, do you find, is it always beneficial for virtual desktops?
So going back to this here, and you see that for some of the personas, there's no GPU and it's not needed. And the reason for that is that the modern CPUs are highly optimized to run GDI applications, GDI Plus, and some of the DirectX applications good enough. In particular, Office. Most Office applications are designed in such a way that they perform really well with a CPU only. So, but only the modern CPUs, and the same is true.
But often you've got to turn off because I think by default they want to use a GPU, and in some
Yes.
instances, if you don't have one, you want to explicitly turn it off.
Yes, and the same is true for video, because the modern CPUs, they have video encoders and decoders built into the CPU, even if there's not an embedded GPU there. And
But even if you're not using GPU workloads or what, like applications that within the session that require a GPU, some protocols do benefit from a GPU just to help offload and encrypt.
Absolutely, 100% correct, because this is where the GPU shines when it comes to the encoding of the videos. Because if you transmit, well, the stream of the user session, which is a video stream, you're encoding video. And if you have a GPU that does all the encoding and does it in a good way, hey, you're golden. But actually, I've found applications that behave in such a way that adding a GPU makes the application perform not so well, simply because it's single-threaded applications and they use some GDI graphics. Now, if the CPU thinks, oh, I have a GPU, so I offload everything that's graphics related, and offloads it to a crappy GPU, then
like your Intel Iris Pro built into your processor or something.
Yes. It is that kind of effect that the admins or those who made the decision, oh, we want to add a GPU and makes, well, as a gift to our users, and then the user says, no, it doesn't perform as well as it did before, and everybody is confused. Yes, there are workloads where the GPU is not beneficial if it's a bad GPU. Good. So do not just add any random GPU. That is the core message here. So it must be both a relatively modern CPU for these first three personas and add a modern GPU for these for the last three personas.
Yeah. We have seen instances where customers don't need a GPU for their applications, but we include one anyways. Configure all the applications to assume there is no GPU to get around some sort of those concerns, because you're right on that. They don't always work as you might expect sometimes. Testing is always important, but it would in multi-user scenarios, it actually helps squeeze out a couple more, squeeze a couple of more sessions onto the box, therefore reducing cost because of that offloading for the codec that was being used for the encryption encapsulation.
I agree 100%.
Traffic.
Multi-user benefits from GPUs because you don't max out the CPU so fast. Yes, absolutely.
Fascinating. Yep. What a fantastic discussion. Very fascinating work that is being done here. Any final thoughts? We're kind of at the top of our hour. Any final thoughts before we close out?
I hope it was helpful.
Absolutely.
And it gave people a different perspective on what end users experience, because sometimes they try to explain you, next time when you hear a user telling you about some funny things they're seeing on the screen, think about anomalies and artifacts.
Yeah, because you're not going to find that based on CPU load on the system.
No.
But yeah, for sure. But Benny, thank you so much for joining us. It's an honor and a pleasure. And you're the only doctor I know, legitimate doctor in end user computing. So that isn't just a random title, bona fide doctor.
I have a PhD in graphics remoting, believe it or not. I learned that from ground up.
I believe it.
Wonderful.
All righty. Thank you so much for having me.
Yeah. And thank you everyone for joining us. Really appreciate your time.
Absolutely. And thank you all the audience for joining us today. Hope this was a great experience, and we look forward to seeing you on our next masterclass. Thank you so much.
Thank you.